Google DeepMind just revealed an AI called CodeMender that's already finding and fixing security flaws across massive open-source projects completely on its own. They've also stepped into a field that's been heating up fast, AI that can actually use a computer. Their new model can click, type, and navigate the web like a person. It's Google's biggest move yet toward fully autonomous AI. So let's talk about it. Alright, let's start with CodeMender. Google DeepMind describes it as an AI code developer for open-source security. The system has already upstreamed 72 verified security fixes to open-source projects in just 6 months. And that's not minor stuff. We're talking about projects with up to 412 million lines of code. What makes this so impressive is that CodeMender doesn't just scan for vulnerabilities the way older automated tools do. That actually understands the logic of the code, identifies the root cause of the issue, generates a patch, and validates it automatically to make sure nothing breaks. All that before a human even reviews it. The agent itself runs on Google's Gemini DeepThink models, a special version of Gemini fine-tuned for reasoning about code. DeepMind says it can debug, patch, and rewrite large sections of code while maintaining consistent style and functionality. So if a vulnerability appears, CodeMender not only fixes it, but also checks for regressions to make sure the patch doesn't create new problems. After that, the patch is sent to human maintainers for review before being merged. One of the earliest demonstrations of CodeMender's abilities came when it found a heap buffer overflow caused by incorrect XML stack management, something that's easy to miss even for experienced developers. Another success story was with the libwebp image compression library, which had a major vulnerability back in 2023 that hackers used in a zero-day attack on Apple's iOS. CodeMender added compiler annotations known as f-bound safety, which forced the compiler to perform bounds checks, effectively blocking buffer overflows. DeepMind even pointed out that if these checks had been in place earlier, that iOS exploit probably never would have happened. Now, the way CodeMender works under the hood is actually fascinating. It combines static analysis, dynamic analysis, fuzzing, differential testing, and SMT solvers. Basically, an arsenal of advanced program analysis tools. These help the AI break down how data flows through the code and where security weaknesses hide. DeepMind also built a multi-agent system within CodeMender, meaning there are smaller AI sub-agents specializing in certain aspects of debugging. For example, one of them acts as a code critique agent, comparing the original and modified code line by line to make sure the patch doesn't introduce regressions. If it spots something off, it triggers a self-correction step automatically. When the system encounters a bug, it doesn't just throw out random fixes. It opens the debugger, inspects the call stack, browses through the source files, and reasons step by step until it identifies what actually caused the issue. In one case, the visible crash report showed a heap overflow, but the AI traced the true cause back to a memory handling problem buried deep in XML parsing. The actual fix only changed a few lines of code, but it prevented the same issue from resurfacing across the entire codebase. Alright, now, building with AI sounds exciting, but behind the scenes, it usually means weeks of trial and error, messy data cleanup, and constant fixes. That's where Neo comes in, and they're sponsoring today's video. Neo is a fully autonomous machine learning agent that handles the entire workflow end-to-end. From raw data and feature engineering to training, tuning, deployment, and monitoring, it gets the job done in hours instead of weeks. And this isn't just theory. On 75 Kaggle competitions in the MLE benchmark, Neo medaled in about 34% across 3 runs, beating many well-known ML agents. It runs in a GPU or CPU sandbox, looping through planning, coding, execution, and debugging until results stick. It adapts when things break, iterates fast, and offers a human-in-the-loop mode so engineers can step in when needed. Neo works on complete ML lifecycle from data exploration to training and evaluation as it scales. Neo could save teams thousands of hours and change how ML projects get done. Early beta is opening soon. Join the waitlist through the link in the description. Alright, now back to Google. Another example shows how CodeMender handled complex object lifetime problems. Cases where you have to manage when and how certain objects are destroyed in memory. The AI figured out that the issue was inside a custom CC code generator and modified it correctly. These aren't simple mechanical fixes. They require deep contextual understanding of how different parts of a program interact. What's even more interesting is that CodeMender doesn't stop at reacting to bugs. It proactively rewrites code to make it safer. DeepMind gave it access to existing code bases and tasked it with securing them by switching to safer data structures or adding compiler-level safeguards. That's where those F-bound safety annotations come in. They essentially turn risky CC code into a safer variant that can't be exploited the same way again. In one example, CodeMender modified functions and then ran them through an LLM judge. Another AI model that checks whether the updated function behaves the same way as before. If there's any deviation, the judge flags it and CodeMender automatically adjusts its patch until it passes. The whole process is like watching an AI pair programmer that not only understands what went wrong, but makes sure every fix is bulletproof before handing it over to humans. DeepMind says this is just the start. They're already working on extending CodeMender's technology into areas like AI-powered ransomware detection for Google Workspace, which hints at a much broader cybersecurity role for AI. The bigger takeaway here is that AI is no longer just a coding assistant. It's becoming a trusted code developer that maintains the world's open-source ecosystem. Now, while CodeMender focuses on fixing code, Gemini 2. 5 computer use focuses on using it literally. DeepMind has now released a specialized version of Gemini 2. 5 that can operate software the same way a person would through a browser or a mobile interface. It's officially called Gemini 2. 5 computer use, and it's built on Gemini 2. 5 Pro's visual reasoning capabilities. This model powers agents that can see and interact with user interfaces. It's available right now through the Gemini API inside Google AI Studio and Virt XAI, where developers can integrate it into their own systems. The core idea is that many digital tasks still require direct manipulation of graphical interfaces. Things like filling forms, clicking through menus, or dragging and dropping files. And this model can do all of that autonomously. Let's take one of Google's demo prompts. The AI is asked to go to a sign-up form on a pet care website, collect data about pets living in California, add them to a spa's CRM system, and then schedule a follow-up appointment with a specialist named Enma Lavar for October 10th after 8 hours in the morning. The model successfully does all of this, navigating the websites, entering data, and confirming the task completion. Another demo shows the model reorganizing sticky notes on a digital board by dragging them into the right categories. It performs all these steps just by interpreting screenshots and reasoning about what it sees. The model works in a loop. Each step starts with a screenshot of the interface, a record of recent actions, and the user's request. The model analyzes everything and outputs a function call like click, type, or scroll. Then the action is executed. A new screenshot is taken and the process repeats. This continues until the goal is reached. An error happens or the system stops due to a safety check or user decision. It's primarily optimized for web browsers right now, but also shows promising results for mobile UI control. It's not ready for desktop operating system level tasks yet, though that's probably coming next. On benchmarks, Gemini 2, 5 computer use performed at state-of-the-art levels, beating other models on online Mind-to-Web, Web Voyager, and Android World. According to BrowserBass's independent evaluation, it also achieved the best balance between accuracy and latency. Over 70% accuracy with an average latency around 225 seconds per full task. In simple terms, it's faster and more reliable than competing systems like OpenAI's computer using agent. Machine Heart, a Chinese tech publication that tested the public demo hosted by BrowserBass, confirmed that the model performs really well on simple tasks like finding the John Wick page on Wikipedia, but starts to fail when tasks become multi-step or language-specific, such as summarizing content or translating it. So it's still in its early days, but the potential is huge. Google has already deployed this model internally. It's being used for UI testing, which can speed up software development drastically. Teams across Google are implementing it in products like Project Mariner, the Firebase testing agent, and even AI mode in search. The model automatically recovers broken workflows by assessing what's on screen and deciding what to do next, something that previously took days to fix manually. External testers are just as impressed. One company, Kaam, said Gemini 2, 5 computer use was about 50% faster and more reliable than any other system they tried. Another company, AutoTab, reported an 18% performance improvement in complex tasks that required precise data parsing.